Hello, fellow mathletes and mathketeers. It's time for some more math enrichment right here with Root Beer. So, what I thought we'd do today is we'd begin a brand new series of videos, contest videos for some math enrichment. And I thought we'd start going through the Friar Mathematics contest put out by the CEMC. So you can find a copy of today's contest on their website. I'll tell you what year we're doing. The Friar contest is part of a set, Friar, Galois, Hypatia. Hopefully we'll do all of them. And they began in 2003 because the year before, the other, Waterloo had two written contests. They had the Euclid, which you're probably familiar with, and the Descartes, which you may not have ever heard of. The Descartes was sort of higher up than the Euclid, more senior paper, and it was designed, it was basically a holdover from when the 13th grade used to exist. So, when basically all of Canada stopped having a 13th grade, they said this contest is kind of silly, why do we have this anymore? So they decided to get rid of it. And then a couple smart people up there said, but then they'll have no practice writing out proofs and solutions, so all of our Euclid answers are going to be by inexperienced students. We can't have that. Euclid is now our prime contest. The grade 12 contest is the one we're going to give out scholarships and things to. So they said, okay, well, we'll take away the Descartes, the really hard grade 13 question, and we'll introduce some smaller, shorter contests at the levels of 9, 10, and 11. Remember, they had 9, 10, 11 grade contests, the Pascal, Cayley, Fermat, but those are all multiple choice. So these ones, the Friar, Galois, Hypatia, they're written contests, so you need to write out your solutions, you need to explain things, and that prepares you for the Euclid, which is a much harder, much longer paper. And that's the one that they really care about, is the Euclid. They want to base scholarships and invitations to the university on performance on the Euclid as well as other things. So with that in mind, 2002 was the last year of the Descartes, so 2003 is the first year of the Friar. It's also the first year of the Galois and the Hypatia, the grade 10 and grade 11 contests. So, to start off the series right, I figured we'd just go back to the beginning. We'll do the 2003 Friar contest. So if you want to, that's a grade 9 level contest. So if you're interested in that, maybe you've got one coming up that you're going to write and you want to get a little practice done, you can watch these videos, and we'll be going through sort of the Friar contests. You can find them on the CEMC website. I can put a link in the description. Past contests, they also have their own solutions up there, as well as I think they give out some sort of level of results. I don't quite know exactly what it is. But you can find the contest. Just try the contest before you watch this video. Pause it. Don't read their solutions. Don't watch my solution videos. Try the contest yourself. See how far you get in the time limit. And that way when you come back, when you read their solutions, when you watch my solutions, you have a better understanding. You can only learn so much just by watching other people. You got to get out there. You got to get your hands dirty. You got to try these contests yourself. It's sort of like homework from class. You understand the material so much better when you have actually had to work with the numbers and manipulate the symbols and everything. That's the whole idea behind homework from class. So your homework, as it is to pause this video and try the 2003 contest for yourself. Really try it. We're going to be going through question by question in each video. So if you got a question really quickly, you can skip over and try, watch another video, or read the solutions that the CEMC made up on their own. That is also available on their website. Okay? So that said, I'm assuming you've paused it and you've tried the contest. If not, I can't force you to. So we can just sit back and we can do some math together. Okay? So how about we take a look at question number 1 on the very first Friar, the 2003 Friar. So I have it up here. So here it is, the 2003 Friar contest, written in 2003, April 16th. I think that's around the same time as the Euclid is written. But obviously, if you're writing a grade 9 contest, you're probably not writing the grade 12 contest. And there's not the usual preamble one would expect from Waterloo contests. It's their first year, so I guess it was a test year. So let's take a look at question number 1. So I can see right away there are 3 parts to this question, and it's probably going to involve this large graph here that says marks on test 1. Okay, question A. The marks of 32 mathematics students on test 1 are all multiples of 10, okay, and are shown on the bar graph. What was the average, or mean if you know that terminology, what was the average mark of the 32 students in the class? Okay. So this question is going to involve 2 parts, or at least a part's going to involve 2 parts. One, we're going to need to understand how to read a bar graph, and 2, we're going to need to understand how to take an average. So if we want to take an average of 32 students, we'll be adding up 32 numbers and dividing by 32, and that'll give us the average. Calculators are allowed on this contest, so don't get too worried about trying to keep your calculations straight or doing them in your head or long computations on a piece of paper. They are allowed on this contest. Okay, so here's our bar graph, and let's just make sure we're reading this right. So all the marks are multiples of 10, 0, 10, 20, and so on. So I see that one person scored 10, because 1 is where the bar for 10 hits. 2 people scored 30 and 40. No one scored 20. No one scored 0. 1 person scored 50. 4 people scored 60. 6 people scored 70. So how many people scored 80? Well, we go to the top and we take a look at what number it reached. 9 people scored 80. 4 people scored 90. And 3 people scored 100. Now, before we even do this question, let's take a look at the graph. It looks like a lot of the data is centered around 80, 70, and 60, and 90. These are pretty high. A lot of people got these marks. Not so many people got the low marks. So whatever average number I get, I would expect it to be around 80 or mid-70s or something like that. Just from looking at the way the data is clustered on the graph. But let's actually work this out. Okay, so we're going to be bouncing back and forth from the graph because I don't have it memorized. But one person got 10, 2 people got 30, and 2 people got 40. We're going to have to add all these up. Okay, so we grab a piece of paper, and or we can just do this straight on our calculator. One person got 10. Nobody got 20. 2 people got 30. 2 people got 40. So we can add up those guys right away, and then we'll keep a running tally because we need to add up the total score and divide it by the total number of students. Okay, these guys grouped to 100, so this should be 150. But we can check that on our calculator. 10 plus 30 plus 30 plus 40 plus 40. 150. Okay, so that's the first 5 students covered. So we go back to our bar graph and we check, okay, what else have we got? 1 person got 50. 4 people got 60. 6 people got 70. 1 person got 50. 4 got 60. 6 people got 70. So 4 people had 60. I can write them all out, or if I'm clever, I can use some multiplication. And 6 people got 70. And we want to add all these up. So we keep our 150 in there because we're doing a running total. So 150 plus 50 plus 60 plus 60 plus 60 plus 60, that's 4 people who got 60, plus 70, plus 70, plus 70, plus 70, plus 70, plus 70 is 680. So 860 is our total answer. Okay, so we can sort of bring that up here. Because we've only accounted for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of our students. We have 16 more to go. There's a total of 32. Okay. So 9 people got 80, 4 people got 90, and 3 people got 100. 980, 490, 300. Okay. So what are we doing? We're calculating the total sum of marks. Why? Because the average is the total sum divided by the number of students. Okay, so that does it. That's 9 80s. We need 4 90s and 3 100s. Alright. So we keep our 860. And then we add in 9 80s. So you could also just add 9 times 80 if you wanted to. 4 90s, or adding 360 to the whole lot. And then 300s. We get a total answer of 2,240. Alright. So to calculate the average, we need the total number of marks, and then divide that by the number of students. Well, we already know the number of students, it's 32, and we just figured out the total number of marks. 2,240, and we have 32 students. So that comes out to be 74 and 2/3. There's lots of ways you can reduce that. Oh, sorry, silly me. Hit the wrong button. Comes out to be 70. Always double check your calculations if you have time, because that could have cost me. I hit the wrong button. I divided by 30 instead of 32, which was a real issue. I was wondering how I got a thirds if 32 only has multiples of 2. So I'll put a little statement. So the average mark of students on test 1 was 70. Okay? And that's all we were asked for part A. So let's take a look at the next part of the question. I'm guessing that questions like these tend to be themed. That's why they're multiple parts. So I'm guessing these next questions involve averages, either calculating them or using a given average to calculate some marks. Alright, B part. After his first 6 tests, Paul has an average of 86. What will his average be if he scores 100 on his next test? So he takes 6 tests. I don't know what marks he's got. You don't know what marks he's got on those. But I do know that the average of his marks is 86. Okay. So if he scores 100, what's his average going to be after that? So just like before, to get an average, we need the total number of marks divided by how many trials we're doing, so number of tests. We know Paul's average is 86. And we know he took 6 tests. So if we know 2 parts of this equation, we can rearrange, do 86 multiplied by 6 and get the total number of marks. So what is 86 times 6? 516. Okay, so after 6 tests, this is his total number of marks. I don't know exactly what marks he's got where. Maybe he's got a 10 or a 16 and a couple of hundreds. I don't know. Maybe he's got just a whole bunch of 86s. We don't know, but we do know the total number of marks after 6 tests is 86 times 6, which is 516. So if I want to calculate his new average, I still need the total number of marks. But he's had an extra test, so now it's over 7 tests. Right, to calculate his total after 7 tests, we need to know what his total was after 6 tests and add on the 100 that he's scoring. Remember, we're assuming he gets 100 on his 7th test. Okay. Well, that's 516 plus 100. So that's 616. Okay. So his new average is 616 divided by 7. Alright, and that, as it turns out, is a very nice number. It's just 88. And we can double check that. 88 times 7, 616. We get a nice little statement at the end. Remember, the Friar Galois and Hypatia, they're written style questions, so you need written style contests. So you need to write out your solutions. You need to explain what you're doing, why you're doing it. You need to give statements so the markers can follow. You get full marks when you give full, complete, clear, concise solutions. So after getting 100 on the 7th test, Paul will have an average of 88 marks. Notice we were able to do that without knowing any of the scores on his previous tests, just the average of his first 6 tests. Alright, so that concludes B part, and I believe there's a C part. There is. Later in the year, okay, so I assume after many tests, Mary realizes that she needs a mark of 100 on the next test in order to achieve an average of 90 for all her tests. However, if she gets a mark of 70 on her next test, her average will be 87. After she writes the next test, how many tests will she have written? Okay. So, unlike the last question where the only thing we didn't know was really the marks of Paul's individual tests, and we could solve for the total sum of them, we've got a little more going on. We don't know how many tests Mary has written, or will have written after the next test. And we also have no idea what her previous averages are. All we know is what her next average will be. Okay? So she needs a mark of 100 to get an average of 90, and she needs a mark of 70 to get an average of 87. So let's get ourselves a new piece of paper. So we don't know how many tests she's done or how many she will do after will have done after the next test. So we can make a little variable for that. We're also calculating averages, and we have no idea what her average on the previous tests were, or indeed what her total sum is. So we can add a little variable for that, and if we can solve for that, that might be great. So we'll let x be that. X be the sum of the marks. And just keep it straight in our head, her previous n-1 tests. N will be the final number that we want. We want to calculate n. N will be the number of tests she will have written after the next test. X is the sum of the marks on her previous n-1 tests. So we know that to get an average of 90, she needs 100 plus her total previous mark sum divided by n. I think it was 87 is her average, and that's if she got a 70. We'll check this in a moment. Okay. But these are the averages we're calculating. So let's just double check, make sure those numbers are correct. She needs a mark of 100 on the next test, so we add the total sum and then we add up 100 and divide by n for the average after n tests. Total mark of 100 gets an average of 90. Mark of 70 gets her an average of 87. Okay, so our numbers are correct. Let's see if we can solve for x or n or something like that and make our lives a little easier. So I noticed that I got a fraction. I have two fractions over here. I might not want that. So we'll rearrange these equations. We don't want fractions with 90 on the bottom. 90 is the number we want. So we certainly should have it sort of up on the top level. All right, we're just multiplying through both sides by 90 in both of these two equations. And this is what we get. Okay. So there's no coincidence that I've written them this way. What I can do right now is, I notice I have just a plus x and a plus x. So what I could do is take this equation and subtract off this equation, or rather substitute this equation in. Okay? So there we can sort of we can just subtract equations. You can always do that. So 90 minus 87, that's 3 times n. 100 minus 70, that's 30. And x minus x, that's 0. So actually, much cleaner. We'll never, well, we might someday know what x was, but we don't need to know what x is in order to get n, and n is the value we want. Right? So we have just an equation involving in just n. 3n equals 30. So we can rearrange that. We can divide by 3 on both sides. say n equals 10. Now n is the number of tests she will have written after the next one. So it's exactly what we want. We don't need to add one or subtract one. I imagine that's a source of confusion on this question. Ooh, accidentally hit the previous page button. But I imagine when the test was written, they probably got a lot of 9s or 10s, 9s or 10s or 11s, people trying to get the right value of n without having clearly defined their variable at the start of the question. They could have gotten confused. That's why it's always a good idea to write things down. It's not just for the markers. Sometimes it's for you to keep it straight what you've done in the past. Okay, what you've tried, what worked, what didn't, what you were thinking. Always a good thing to do. You can always erase things or cross them out. So after her next test, what was her name? I want to get her name correct. It was Mary. Alright. So after her next test, Mary will have written 10 tests in total. Alright, so we have a nice little statement. We've written out everything we're trying to do. We haven't been too laborious with it. So after she writes the next test, how many tests will she have written? 10. Okay, so that does it for that question. We have answered all that they were asking for. Okay. And that concludes question number 1. A very nice, very good first introductory question to the first friar ever. And that about does it for this video. Next time we'll go through question number 2, which, just a cursory glance, we'll probably be using the variables x and y because we're talking about Xavier and Yolanda. But we'll get to that in the next time, so I hope you've enjoyed the 2003 Friar. If this one isn't your speed, or if you think it's too old and out of date, feel free to skip to another video. I'll be trying to go through all the Friars, all the Galois Hypatias. Always, always remember, guys, try these contests first. Really, it's the best way to learn. A great man I once knew said math is not a spectator sport, and that is so true. Try these contests, then come to the videos, then read the solutions. You will learn so much more. But please join me in the next video, or indeed in another contest video, or any other video on my channel. And if you like this contest, give a like to the video, or leave a nice little comment below. But other than that, I will see you guys in the very next video, where we'll be doing question number 2.